Ampere's original law described how electric currents create magnetic fields. It says, the curl of the magnetic field at a point is proportional to the electric current density at that point. Curl from Ampere's law tells us that currents create circulating magnetic fields. Remember, curl measures rotation. Imagine a tiny paddle wheel placed in a magnetic field. If the field circulates around the wire, the paddle wheel would spin. That is curl rotation. Hence, Ampere's amount of rotation. Ampere's law says the amount of curl is proportional to the current passing through the wheel. Ampere's law worked for steady currents, but it failed for circuits with capacitors. The current appears to stop at the plates, but a magnetic field still exists. So, what creates that magnetic field? Here is a capacitor. I place a magnetic field detector, a Hall probe, between the plates. With no current flowing, the meter reads 0, no magnetic field. Now I turn on the power supply. The capacitor charges. Watch the meter, a magnetic field appears between the plates, but there is no current flowing across the gap. So what is creating this magnetic field? James Clerk Maxwell saw the problem. He realized that a changing electric field, even without a current, can create a magnetic field. He added a second term to Ampere's law. Mu naught, epsilon naught times the rate of change. This term is called the displacement current. Between the capacitor plates, the electric field is changing as the capacitor charges and discharges. That changing electric field creates a magnetic field. Even though no charges are flowing across this field, the electric field is changing fastest. The magnetic field is strongest when the electric field is changing fastest. This is Maxwell's displacement current. This is the complete Ampere-Maxwell law, the fourth of Maxwell's equations. It says there are two ways to create a magnetic field. First, electric currents moving charges. Second, changing electric fields even in empty space. This second term is Maxwell's genius. Here's the revolutionary consequence. Faraday's law says a changing magnetic field creates an electric field. Ampere-Maxwell says a changing electric field creates a magnetic field. Together, they describe a self-sustaining wave. The electric field creates a magnetic field, which creates an electric field, which creates a magnetic field propagating through space. Maxwell calculated this speed as found in the speed of light. Light is an electromagnetic wave. Maxwell died in 1879. In 1888, Heinrich Hertz became the first person to generate and detect radio waves. He used a spark gap transmitter and a receiver across the room. No wires tapped race when Noel was raced. The unit of frequency, the Hertz, is named after him. Maxwell's equations revealed that the speed of light is a fundamental constant of nature, is a constant rate. This constant speed is the same for all observers, that are Pater-Kalberger-Einstein to special relativity. Maxwell's equations enabled virtually all modern technology: radio, television, microwaves, cell phones.